If we look at this do now, we want to expand the following. So remember, when we have something that's raised to a power, we can't just distribute the power when there's a plus or a minus in between. So the x plus y squared, we can't just make that x squared plus y squared because of the plus sign. So we have to write it twice and FOIL it out. So when we go to FOIL this, and we'll get x squared plus xy, and then we get yx or xy. Because it's multiplication, it doesn't matter the order, so we're just call it xy again, plus y squared. So we can combine our like terms together, and we get x squared plus 2xy plus y squared. Okay, so now if we have to do x plus y to the third, we have to write it 3 times and FOIL it. Well, since we already wrote it twice and FOILed it, we can just take the extra x plus y and now FOIL it with our answer from the first example. Okay, so x times x squared is going to give me x cubed. X times 2xy is going to give me a 2x squared y. And then I have xy squared. And then I have x squared y. I'm going to go down to the next one. So that's going to give me 2xy squared. And then I get y cubed. Okay, so we want to combine anything that's similar. So the x cubed is the only thing that has an x cubed, so we'll leave that. Now I have a 2x squared y, and I can combine that with any other x squared y. So I have another x squared y here. So that's going to be 3x squared y. And now I have a xy squared, and I can combine that with any other xy squared. So I have a 2xy squared. So that's going to give me 3xy squared. And then I'm left with my y cubed at the end. Okay, so x plus y to the fourth would be the same thing. We would take the answer that we just got from x plus y to the third, and then FOIL that with x plus y. Now, I doubt that anybody actually wants to FOIL these out, especially if you have x plus y to the 10th. That's going to be a lot of FOILing. So there's a thing that's called the binomial theorem. And we're going to be able to expand binomials using this binomial theorem, which includes Pascal's triangle. And it's a kind of a shortcut to help us expand binomials. So if we look at this chart, okay, if I have x plus y to the 0, that's going to equal 1. Right? Anything to the 0 power is 1. So if I have x plus y to the first power, that's just x plus y. And there's 1's in front because the coefficients are a 1. We don't need them there, but they're there. If I have x plus y squared, we just did that in the do now. So that's x squared plus 2xy plus y squared. So let's put that in. X squared plus 2xy plus y squared. And x plus y cubed we just did. So that was x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, if we did x plus y to the fourth, we would put the next one in and so on and so forth. But we want to look at this, and we want to see if there's any kind of pattern that we see. So, x plus y to the fourth. Well, I'm going to start with x to the fourth here, and I'm going to end it with y to the fourth. Because that's what it looks like happening with all of the previous steps. You have x and y in the end, you have x squared, y squared, x cubed, y cubed, so x to the fourth, y to the fourth. Now the inside is where it gets a little tricky. Okay, so I'm going to fill this in for you. So on the inside, we're going to have a 4x cubed y, a 6x squared y squared, and a 4xy cubed. Okay, so continuing down, I'm going to go to the fifth row. So x plus y to the fifth is going to give me x to the fifth plus 5x to the fourth y plus 10x to the third y to the second plus 10x squared y to the third plus 5xy to the fourth plus y to the fifth. And the last row, we'll have x to the sixth plus 6x to the fifth y plus 15x to the fourth y to the second plus 20x to the third y to the third plus 15x squared y to the fourth plus 6xy to the fifth plus y to the sixth. Okay, so if you're looking at this, you may think, where are these numbers coming from? How did I get these numbers? So we'll come back to this in a second. Okay, so we want to describe any patterns that you see in the exponents of the x's and the y's. So if we look at these, if we focus on just the x's, okay, if we look at the first x plus y to the first, the exponent of the x is a 1. If we look at x plus y squared, okay, the x squared is first, and then we have x to the first, and then the last term, that because it's a y squared, it's really like x to the 0. There's no x there. So in the third, x plus y to the third, we have x to the third, and then we have x squared, and then we have x, and then we have nothing. So what's happening with my x exponents is that they are decreasing. So x plus y to the fourth, the exponents on the x are going 4, 3, 2, 1, nothing. And x plus y to the fifth, 5, 4, 3, 2, 1, nothing. So they're constantly going down. So we'll say the x's are decreasing. And if we look at the y's, in the first example, like x plus y to the first, we have a y. We have no y first, and then we have a y. X plus y squared, there's no y to the first, y to the second. In the third one, we have no y to the first, y to the second, y to the third. X plus y to the fourth is going to give you 0 y's in the first spot, then y to the first, y to the second, y to the third, y to the fourth. So all of the y's are increasing here. So the x's are decreasing and y's are increasing. So that's important because that's a pattern. So as we continue that on, we know what our exponents are going to be without having to FOIL all of this out. Okay? And describe any patterns you see in the coefficients. Well, this is going to be the symmetry and Pascal's triangle. Okay, so Pascal's triangle, that's going to give us all of the coefficients. So all of the numbers we have in there, all the numbers before our variables. So when we have 1x plus 1y, those 1's are our coefficients. 1x squared plus 2xy plus 1y squared. 1x to the third plus 3x squared y plus 3xy squared plus 1y cubed. All of those numbers in front are my coefficients. So if we don't know Pascal's triangle, we look it up. So we're going to write it below. So Pascal's triangle, it looks like a triangle. So you're always going to start with 1 on the top. Okay, and then on each side, you have a 1. So if you look back, okay, the first thing that made x plus y to the 0 was a 1. X plus y to the first, the coefficients were 1 and 1. Okay, so as we're going through this, the outsides are always going to be a 1. The insides are going to be the sum of the 2 above it. So 1 plus 1 is going to give me 2, and then I have 1 on the outside. So 1 on the outside, 1 plus 2 is 3, 2 plus 1 is 3, 1 on the outside. 1 on the outside, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 on the outside. 1 on the outside, 5, 10, 10, 5, 1. So continue this. 1, 6, 15, 20, 15, 6, 1. And we'll just do one more. So 1, 7, 21, 35, 35, 21, 7, 1. So it's symmetric. The numbers are going towards the middle, and then they start to go back again. So it's like symmetry. The top at 1, that represents row 0. Okay, so it's the exponent. If I have x plus y to the 0, it's 1. So row 0, this is now row 1. This one is going to be row 2. This one is going to be row 3. This is row 4. This one is row 5. This one is row 6. And this one is row 7. Okay, so if they ask for, the third row, you're not just going 1, 2, 3, my third row is 1, 2, 1. It starts at 0, so you have to go 0, 1, 2, and 3. Okay, so here's an example where you have some kind of binomial. It does not matter what A and B are. You're always going to apply the same thing. So P0 just means the Pascal's triangle, row 0. Pascal's triangle, first spot, second spot. So it depends on what row you're looking at. So it's the 0 spot, the first spot, the second spot. And then the exponents, you start off with n, and then n minus 1, because those are going down, and there's no b in the first spot. So then it's b to the second. So the y values are the second, whatever's in the second spot, those are going to be going up in exponents, and the first spot is going to be going down in exponents. Okay, so we're going to look at an example in the next video.